it has not been affected you too much. Okay, so um, when I was talking to Anna, she reminded me that I have been working on measurement for a long time. So I started working on measurement about 19 years ago. Um, yeah, at the time, I was asking a very simple question. I wanted to understand what was the pass-through of food prices to the inflation rate of the poor in Central America. It was a very specific question. And my view is that I had just visited Central America and I noticed that the poor were suffering tremendously, tremendously. This is 2001. And but the economies, and when you read the news, the economies were doing great. I mean, inflation rate was going down, the growth rate was high. And I remember I was in this meeting with all the presidents in Central America, and I said, you guys are going to lose your job in the next election. And the reason is that you are not measuring how much the poor are suffering. Between 1998 and 2001, the price of oil increased by 4 times, the price of food increased by 5 times, real estate was increasing by 15% every year. And I said, guess what the poor consume? The basket of consumption of the poor has food, transportation, real estate, and an iPhone. That's it. They only have one item whose price is going down. Everything else is increasing by 100% per year. I said, you measure the inflation rate in the cities, not in the rural area, you are going to lose your job. And in fact, every single one of the presidents, except the dictator, by the way. The only one that didn't lose a job was the dictator at that time. He still is a dictator. So, but everybody else lose their job. And I realized at that time that we were not collecting the proper data sets. And in fact, I worked for many years to try to collect that from official sources. And then I decided that it was important to start collecting data by myself. So I created a project that is called the Billion Prices Project. Let me just talk slightly about that and show you a little bit of what we have done. And this was with a student, Alberto Cavallo. He was a student at MIT first as an MBA, then he went to Harvard to do the PhD. So in the interim, we started working on this. So the idea was that we went to online data sources, so online supermarkets. This was the year 2006. So internet penetration was relatively small. And the question was, can we construct an inflation rate using data from supermarkets? And it was actually about food, because actually my question was about pass-through on food. But by the way, between 2001 and 2006, I was just desperate trying to find a solution, was visiting many statistical offices, and very, very unsuccessful. I think I visited 39 statistical offices on Earth, 39, and they were all pathetic except one, which was Hong Kong. Hong Kong was the only place on Earth that they actually had the prices of food for the poor. The only place on Earth that I found. And by the way, I didn't visit Russia, so I don't know Russia, but anyway, but 39, that's a lot. So I visited every Latin American country and I said, this is pathetic and so on. So the US didn't have it, etc. So in some sense, even very rich countries had no information. So with Alberto, we started downloading data online, first on food, then on electronics, then on clothing, then on services, restaurants. And at our time when we were downloading this data from the internet, the restaurants have PDF menus. So we had to take the PDF, do object character recognition, and then actually collect the prices. And we had to collect like median price of an entree, median price of a dessert, stuff like that. So we started collecting all the goods, and then we became better and learned how to collect the price of electricity. There was a moment in time in the Sloan School, roughly when Anna was graduating, that 3/4 of the servers of the Sloan School were all mine. I actually had, so I had a massive capacity. I was using 30% of the supercomputer of MIT, and I was actually just downloading prices every single place. It was called the Billion Prices Project because, just to give you an idea, in the United States alone, every single day, we download more than 250 million products every day. So I wanted to compute inflation rates faster, better, more accurately. And and I remember there was a moment in time when the server was just overwhelmed, and at MIT, the dean was unable to send an email because it was so overwhelmed. But I have convinced everyone in the information technology, I mean, all the people that are in IT, I convinced them that they could do two things in their life. One, to install Microsoft Windows in the computers of the faculty, or help me save humankind. I said, you can do whatever you think is more important. So I manipulated everyone in IT. So they were all working for me. So when the dean cannot send the email, he calls the people from IT and they said, guys, I cannot send an email. And the people from IT says, yeah, Roberto is running his billion prizes project. I said, you don't have access to the email until 4 p.m. So the dean says, what? Like, I need to send this email. And the guys from IT said, and we cannot stop saving humankind. So, so the dean sent me a very nice email at 5 p.m. Just so, but the nice thing about that is that actually we created a spin-off and we created a company, and in fact now this is there are more than 35 people working on this. I just want to show you about the possibilities. So this is about measurement in the end. One of the biggest points that we had was when Argentina started manipulating the inflation rate. We were the ones that proved that. In fact, several courts and several judges in the world have used our data to clear claims about manipulation of inflation rate. Okay, so let me just show you, let me just share. I'm going to connect to, let me just check that it's working. Let me just check. Yes, it is. So let me just show you, this is my research dashboard. So you can see more or less what we do, okay? And I'll show you a couple of things of what we're doing. So can everybody see a web page here?
Yes.
Orange and a blue line. Okay, yes. Let me show you first United States. So I'm going to show you two lines. One is a blue line, the other one is the orange line. The blue line is what we produce every single day. That's our indicator. 100% of the data on the blue line is collected from online sources. And again, it's about 250 million. There are some sectors that are missing here, like education and health, that we make some estimates. But this is the data that goes all the way from 2000 and mid-2008 all the way to today. Just first, pretty accurate, don't you think? They seem to be very accurate. We use very little information from the statistical office. In fact, the head of the Bureau of Labor Statistics has used this graph several times to defend herself in front of Congress. When the Congress of the United States was accusing the Bureau of Labor Statistics of manipulating the data, I mean, she's a very close friend, so, you know, and I became very close friends with many statistical offices, okay? Because I'm not here to substitute them. But she calls me and said, Roberto, can you send me your graph? By the way, at that time was about this time. It was before Trump, so it was about 2015, around this time. So it was only that part of the graph. So she calls me, I send her the graph, and then she presents this in Congress. Said, well, if you think that I'm manipulating, somehow these crazy people at MIT get the same number that we do. And in fact, so she said, it's not like we're manipulating the data. And it's not that we're trying to track what the MIT people are doing. We just are measuring the same thing. So now they're not identical. One thing that I want to show you is, for example, by the way, this peak here, I don't know if you can see, that's the 16th of September of 2008. That's one day after Lehman is when this decline we see. Let me just show you a little bit of what happens the last year, so you have an idea about how these indexes look in the short run. And this is very typical of what happened to our data. Online prices tend to move significantly earlier than offline prices. Because in offline, the prices that are collected in statistical office, they tend to be collected offline. And this happens in almost every country. I'm going to show you in a second some countries of interest. Is that okay? But you see, we see the decline significantly earlier than the decline. In fact, when this decline here, that is actually the announcement of the inflation rate of May, is actually done at the middle of the next month. So this decline here is truly not known in the financial markets until about this time. So the May inflation is announced on the 20th of June. Well, the May inflation, we have it. By the way, today is the 9th, no? And it's 10 a.m. in the US. So I don't have the inflation rate of the US yet, but that dot there is the last point that we have. That's the inflation rate of yesterday. By the way, at 4 p.m. today, I have the inflation rate of every single country on earth that we compute. So we compute this really, really fast. And again, you can see the trends. Now you might be wondering, which country do you want to see? I don't have all the countries here, and this is my research. Do you want to see Russia? Maybe.
Roberto, also, it's a question. It's relative to some point in the past. Yeah, it's not. You're not saying by how much current inflation sort of statistics differ.
Well, I will have the month-on-month inflation rate here. I'm just showing you the index above. Yes. So we have to normalize the data. So every time I change the window, because this is my research portal, okay? So I have chosen to always normalize the data to be 100 at the beginning, you see? So the stuff going up, so the inflation rate, for example, in the US would have been 40 basis points in the months of January, and then 20 basis points in the other, and so on. So this is the changes will be down here. But I don't pay too much attention to the changes. But anyway, so this will be actually the announcement. So this is the 40 basis points announced by the Fed, by the BLS. This is minus whatever, 10 and so on. So this will reflect that. So
Roberto,
yes, all the questions should.
So is a difficult part of this, so you can find the price changes, but as far as like weighting the baskets and substitution between different goods.
Yeah, so
how you guys figured out
how to do beautiful. First, the substitution, we did not invent the substitution. The substitution of products is in the manual of the British Statistical Office. They have a procedure that is called overlapping qualities. That means that two products are sold at the same time in the store, and that's how you concatenate the pricing series. And they said, because we don't collect the data frequently enough, we cannot implement the best methodology. So we have chosen to do hedonics, which is what the US does. But we discovered that by reading the manuals of the Statistical Office in the UK, and I say, like, you have to be kidding me. I think this is exactly what we can do, because by collecting the data every day, what happened is that I have the iPhone. I mean, I think this is iPhone. I think this is a new iPhone, and this is the old iPhone. So okay, I have two iPhones. Is one is mine and my wife. And so my wife is the new, mine is the old, just for the record. But these two iPhones here, you see, what happened is that the Statistical Office collects only one of them. But you see, I collect all of them. So if both are sold in the data, there's a period of time in the time series where both will be sold at the same time. And that's how I can actually construct an index. I only need 2 days to construct an adjustment of substitutions. The weights, what we do is we use a power law. It's super simple. We know which are the items that are sold the most because they are presented on the web pages that way. And then what we do with those items that are sold the most, we just put a power law. So it's a geometric. Now, our categories are super narrow, though. So, for example, it will be, for example, pasta, barilla, spaghettis, okay? A 1 pound box. So it's super, super specific. So within that, we can actually do just a power law for the inflation rates that we observe. Now, once we have that, then constructing the index, we use the weights from the consumer expenditures. Let me just show you Russia.
Sorry, Roberto, just a follow-up question on this. So with this approach, it looks like you can double, basically methodological, you can check how good is the hedonic prices approach of the banks are using.
Yes, we have done.
And how good it is, like just for us to know.
Yeah, so in a 5-year window, so depends on the product. Ruben, great question. So electronics and clothing are the two most difficult ones for hedonics because of the product rotation. All the other sectors, I would say that hedonics is perfect, okay? So it's, the error is tiny. On TVs, the errors wash out roughly every 3 years. On clothing, they might last a little bit longer. So depending on the country. So for example, in Chile, the mistake was about 10 years. In fact, they have to redo the index. So there were many mistakes in that. So clothing and electronics are the most difficult ones to do. So there's mistakes. But I just wanted to show you Russia. You see, By the way, as you can see, this is, I am not a trader, but you might argue I should, because, you know, here, see, I see the price level in Russia going down. Guess what? That was just announced. And the next one will come soon. Now, do you remember that Russia was accused a couple of years ago about manipulating the data, that these indexes were? So if that is the case, you should observe. Let me show you, well, before showing you manipulation in Russia, so you don't get too excited, let me just show you sorry. Let me show you the UK. So you can see another country. UK is the most accurate country we have, because we do have health and education and everything. Just very, very impressive. UK is just, everything is online. Everything. Prostitution, you find it online, everything. Absolutely every single product you can find easily. So I wanted to show you, but for example, Greece is not as good. There will be a discrepancy between the blue and the orange line. Now you can see that volatility, Ruben. That volatility is the clothing prices, my friend. That volatility on the orange line, which is the official is super volatile, is all the discounts on clothing. You can see it's actually every 6 months. Here, every 6 months. And that's because they include in the index the discounts, the severe discounts of 75% that you put at the end of the store. They collect those prices. Say, like, you have to be kidding me. That doesn't exist online, and that's why our prices are smoother. Now, Greece is a much more volatile series, as you can tell. And we have countries like Brazil, for example, that is quite accurate. Okay, so so now let me just show you.
Roberto, may I have a question? But
yes.
Did you notice some difference from 2020, starting from 2020? Because like with the COVID,
yes,
many countries went online. So did you notice some changes?
Well, I saw in rate of food. What a great question. So first I want to show you a little bit of Russia. So you see, the last 2 years you have not manipulated. Is that clear? Because this is a proof, a little bit. I mean, it's very little manipulation. If you go longer, you will see some manipulation, okay? You will see a discrepancy between the two lines. Oh, sorry, that's Brazil. That's Russia? Wow. I didn't know it was that good. I thought it was more manipulative. They're making me look bad, those bastards.
Maybe I will be the first, not like British guys.
All this baseless accusation of Russia.
Yeah, baseless. I will find it, Ruben. You will see. Yeah.
That's the real research based on data.
Yeah, those bastards actually are not manipulating. But let me show you a little bit about here. Let me just show you 1 year of data. Let's say a month. Let's say 9 months. Okay. So I get the COVID crisis. So one of the very interesting things that we saw was this: the price of food. See, this is Germany. The price of food increased from the index of 100 to 104. That's 4% increase in price of food is roughly during COVID. Isn't that impressive? By the way, we have the peak and then the decline. And again, it's what you said, Medina. It's like by people shifting their preferences out of restaurants to more eating at home or delivery, you see a spike. Now, we did not see a spike. In most developed nations, there was no spike on prices online in general. Even though people move more to the online, most developed nations, the price online and the price offline, online and offline, they tend to be very similar. So it was not a lot of big movement. There were a lot of stockouts. One of the projects that we are doing is stockouts. Because we collect the data from the retailers, we also know when the product disappears. You see, I collect every day, so I see tomato, no tomato, so I assume it's out of stock. Is that okay? And then tomato comes back again. Toilet paper is gone, and then toilet paper is back again. So this is the number of stockouts on food products. That's 100. Yes, so that's food products, and this is the aggregate in the United States. You can look at other countries. and this is Germany. So this is a percentage of stockouts. So let me see if we have, let me just look at longer. This will be longer. So yet you see exactly when COVID started. So here you can see that in Germany, they are not at the level that they used to be in terms of the stockouts. Interesting, isn't it? So, yes.
So one quick. So you're showing indexes, values across countries, but you could go subnational, right?
Yes. Yes. And in fact, actually, I can go through a category, Michele. So you're Italian with that name, Michele?
Yeah, I am. Yes.
Excellent. Yes. So in Germany, yes. I mean, not all the. So when I say yes, not all the countries. We don't collect from every city on earth. We could actually. So, for example, I'm doing another research which is entirely on price dispersion within countries. I'm doing that with Diego Aparicio, and we're collecting a group of items in every single location in a country. So we're doing something which is the opposite. Instead of here is collecting a lot of items, in the other one is collecting few items on many locations. Very difficult to collect both, by the way. The data is just too big. We have about 1 terabyte of data per week on this project.
Also, so the difficulty is only there to manage the amount of data. It's not that you need to get something more. So you could get systematically inflation at the NUTS 3 level for all the Europe.
Yes, absolutely. In fact, there's a paper in my webpage called Quantum Prices. The appendix, if anyone is interested, okay, the appendix of that paper explains exactly how to download the data. Okay, so you don't have to do anything. I mean, you still have to program the crap. Is that okay? But it explains exactly how to download the data. Anyway, I wanted to show you some of that project before going to the presentation. So I have been working on measurement for a long time. So measuring of economic activity, as you can see, we started that with Thailand in 2012. Measuring stockouts. So this is just the recent data, but I have been measuring activity and trying to get measurements of the economics for a long time. And it's so I work a lot on the economics, but the last 6 years, and by the way, the usual way I start is I am very critical. So I tend to go to any index and I start by saying what is wrong with the data and what is wrong with the construction of the index. So I don't get many friends at the beginning, I have to say. they are and then, by the way, they for some reason, I don't know, maybe because I'm friendly, they start sharing their personal stories, and then they use the stories publicly. So it's just like it's like super embarrassing. So anyway, but Doug, yes.
Sorry to interrupt. I was looking for a good time to interrupt. I would imagine hedge funds are quite interested in this data. So, do Renaissance Technologies and D. Shaw purchase this data? I'm curious. Or you probably can't say.
So this actually, in order to be able to finance this project, we had to create a private company because this is extremely costly. So we distribute these indexes to the financial sector. That is correct. That's so the portal that I show you is the one that I use for research. That actually the data that I show you still is not in the financial markets. They delay the release to the data to the financial markets a little bit more. The contract, or at least the thing that I was pushing when we signed that contract, is that every central banker could get the data from the data provider if they wanted to get the data. So Chile wants to get the data, so they go to this is distributed by State Street Bank now. So they will go to State Street Bank and they purchase the data from State Street Bank at a relatively cheap price. So the countries get the data. There are some countries where we actually provide the raw data. So I don't think I can mention, but there are many countries that we actually provide the raw data. We collect the raw data and we put it in a server for them. So I don't know what they do, and in fact, I keep telling them that there's a very important aspect for me of privacy, that I don't want to know what they do with the data. I said, you asked me to give you the data of certain establishments. I put it in a server. From then on, it's your responsibility. And do not even ask me a question what to do with the data, because it will reveal private information that somehow will jeopardize, you know, what is happening on financial markets. So I have to, but we do share this with the statistical offices. And both Alberto and I are kind of in the scientific committees of many statistical offices. So we have explained this to everybody. But the paper with Diego, the one that says quantum prices, I decided, you know what, I need to explain people how to do this. So any human being can do this very easily now. It's super easy. Now you need computing power, so do not expect this to be run. I mean, you can run it on your laptop, but yeah, it's gonna be. And let me actually write the name of the paper. So it's quantum prices. Okay, so with Diego Aparicio. Okay, so but let me explain. So I know this is cool, but I am tired of measuring inflation. 19 years, pretty much enough. So I move from one topic to the other. I usually don't stay more than 7 years in any topic. So truly, you know, several years ago, I decided that I wanted to think about measuring other aspects of the economy. And in fact, this started because some student asked me a question in the class, how will I measure human trafficking and modern slavery? That was the question. So it was very interesting. It was a class that was talking about big data and how you can use to have a hybrid approach. I was saying that the key of what we have done in the Billion Prices project is to take the big data, the one that you collect from these data sources, and combine that with the survey data. See, there's something very nice about what the statistical office does every time they collect data, is that they think very hard about the representativeness and the importance of every data point. So every data point is very meaningful. When you go to the internet, what happens is that every data point is very meaningless. Now, you have many, but they're very meaningless. So when people only use data from Twitter to make any assessment, that tends to be a very bad assessment. They will be good for 2 weeks, they will be good for 2 months, but after that, they are done. And the reason is that the nature of the data in online changes too fast. And therefore, what you did today very likely will not be useful in the future. That noise that you're hearing is my dog. She's super old. She's 14 years old, and I have to be with her at all times. Otherwise, she gets an anxiety attack. So I'm sorry for the jingling, but it's just my poor dog is just super sick, so I need to be with her. So I apologize for that. So, but when you rely only on Twitter, only on Facebook, when you rely on only these data sources or only online prices, you are very likely to be severely biased. And this discussion, I remember I had this discussion with Amazon. They said, we can compute the inflation rate of the United States perfectly. And I said, yeah, you could. I said, but I know you will not. And people, what do you mean? I said, well, you have no capacity to understand what is required. And they said, oh, we can take all our products and compute the average. And I said, okay, all your products. I said, let's talk about books. How many books do you sell? By the way, I didn't know. They sell 23 million books, okay? I didn't know. They tell me 23 million books. I said, okay, that's good, that's good. And I said, can you check if you sell my book? I have written a book, a really bad book. In fact, I have only sold 4 copies, and I have 5 members in my family, okay? So it's an awful book, okay? It's a completely useless book, okay? It's something that I edited for the Inter-American Development Bank. So they were selling my book, which, by the way, on that day, it was on sale. So I said, well, good for you that is on sale. Let's see how many people, let's see how elastic this demand is. Anyway, and I said, okay, so how do you wait? How do you actually wait? Because actually from the 23 million books, truly only 100 are representative. And I said, how do you know in your data which 100 you should have? I said, I'm pretty sure mine should not be there. I said, I will put a weight of 0 on the prices of my book. It's not about popularity. And your sales, and I said, the sales of Amazon might be representative of the 8% people that buy in Amazon. It's not representative of the 100% that purchase books. And I said, so whatever you do is going to be a very bad index. I said, you can try. It is complicated. We need to understand that the data online is severely non-representative. So my approach is a hybrid approach where I combine what I call the big data with the small data. See, the statistical office is slow, okay? It's very infrequent, but it's incredibly representative because they are designing to do that. So if you take the two data sets, you can construct much better you can get much better information, because the idea is that you correct the biases of the big data by using the accuracy of the small data. Okay? In fact, I usually don't teach it that way. I usually teach fast data and slow data. Is that okay? It's kind of that's kind of the way I describe it. I started big, so I have to shoot small. But the big data is big and fast. The other one is small and slow. So that is kind of the approach. So I was teaching this class, and this student asked me, like, how can you measure human trafficking? And in the middle of the class, I said, like, what an extraordinarily good question. I said that, and I said, okay, let's think about it. And in fact, actually, I changed my whole class, because that class I taught about human trafficking, and then I sent an email to all the students that the following class I was going to talk about forestry, and then the next one about fishery, and that I decided that that question was so important that I decided to change the class. That I wanted to think about, all together, how we can measure human trafficking and human slavery in different activities. And that day I decided that, inflation rate was important. That was important for hedge funds. But I thought that I had to measure other issues that were, as important or more important, and that they received no attention. So I started actually working with the military and the United Nations and Interpol on humanitarian help about human trafficking and refugees. Then I started to move to things like discrimination, so I have moved away from inflation rate. It has been a long, long time that I still write papers, but it's mostly from students that come to me and says, let's write a paper on this and that. But truly kind of my interest now has been mostly measuring the ethical behavior in the world. So I want to understand how can we improve the way we measure our ethical behavior. And that's how do we treat the environment, how do we treat each other, and how you treat yourself. So how I treat myself, that's also an ethical issue. So I'm developing methodologies to measure, so things that deploying technology and thinking about and working with a lot of engineers to think about, well, how can I use my phone to learn about myself? And I will show you one, which is a really nice exercise. I will please ask you not to enter on that webpage right now, because we are running the experiment right now. So I'm going to show you a webpage. Please do not enter. If you can wait a little bit. I promise I'll send the email to Anna, so she will have the URL from the webpage. But the idea of that webpage is that is to learn ourselves. So how when we make a decision, how do I weight two different social causes? So when I'm designing a COVID and I'm deciding to lock down people, I am implicitly deciding how I want people to die. Because, see, in Germany, if I send people home, very few of them will die of starvation. Very few. And very few of them die of domestic violence. But when you do the exact same policy in India, you're actually choosing how you want people to die. And we have not even an idea of how we will weight a death in a hospital versus a death on domestic violence. How do we choose between the two? Now, we would like both to be zero, but that's not what happens in reality. So truly, we don't know about, how much should we slow down growth in India to protect the environment and those aspects. So there's an aspect about knowing each other and then knowing the societies. So let me tell you a little bit about what the paper does, and then I'll tell you a little bit about the solutions. The paper, as always, I start in a very destructive manner. So the paper is mostly about destruction, and I will do a fast summary and I'll explain you a little bit of the methodology, but then shoot me questions. And then at the end, I'll show you the webpage. So if you want, you can actually do your survey. So you get to know yourself, okay? By the way, this is gonna be changing after the experiment for sure, because we're doing the experiment to create a base for the exercise, and also to understand what we want to change. I mean, this is the third test that we do. So this paper is with two postdocs at MIT, Florian Berg and Julian Köbel. Actually, both of them are in Switzerland right now. We wrote this paper to highlight two things. One is something that was very well known in finance and in general, is that people measure ESG ratings very, inaccurately. So let me explain what it is. In finance, about 1/3 of the assets worldwide now are depending on something that is called ESG ratings. E stands for environment, S for social responsibility, and G stands for governance. But by the way, everybody can see the slides? I forgot to ask.
Yes, it's good.
Okay. So in the world, these ESG ratings are trying to measure the ethical behavior of firms. So it's kind of coming back to what I said. They don't have that interpretation, and I don't know why. But anyway, that's what it should be. So like how badly I'm treating the environment, how badly I'm treating my workers, how badly I'm treating my consumers, how badly I'm treating my competitors, how badly I'm treating, my suppliers, etc. So this is to me, this what you're trying to measure is intention, how badly you treat other people. Their outcomes about how much I pollute, but also I would like to know what is my intention, because I might have a big intention of not polluting and I have an accident, or vice versa. I'm a bastard, I'm a lucky bastard that I am just super irresponsible and I have not polluted. So both things matter. So intentions and outcomes. So what you would like to do is to measure those aspects. So in general, people, they're right now, when we started the paper, there were only 200. Right now, we have about 250 companies that either produce data, aggregate data, or produce ratings and a ranking. They all produce a ranking, actually. So 250, that's a lot. So we did not analyze all 250. There are some that are the top 10. We got data from the top 10. There are 2 that are based on news that we discarded. Is a very different data source. So from the other 8, we contacted all 8 of them and requested their data. And in fact, 6 of them gave us the data. Actually, all 8 gave us the data, but 2 of them we couldn't do something that is called the taxonomy, which in a second I will show you. So actually, everybody gave me the data. I told everybody that I was planning to write a paper to show how inaccurate is what they were doing. So I have no idea why people give me data when I actually make that statement, but might be the Latino accent. I have no idea why, but they give me the data somehow, which is, to me, is mind-boggling. But anyway, I am thankful for their willingness to be subject to this exercise. So so there are 2 purposes here. One is to understand how big the discrepancies are, and the second one is to understand the source. Okay, so what I'm going to do is to jump around. Okay, the paper is long. It's a paper about a decomposition. It has 0 economics right now. Okay, this is about just to show how bad this is. But this is important. In finance, we have hundreds of papers written on ESG, where people just look at what are the returns on ESG. So you put ESG. What are the returns on social corporate responsibility? Oh, I have child labor, not child labor. What is the impact on the stock returns? What is the impact on the portfolio, etc.? We have hundreds and hundreds of papers using this data, okay, in some form or shape. I actually think that a lot of those papers need to be redone now. Not clear if those results will sustain the robustness of different data sources. So our purpose was to have an understanding of what was inside the data. So let me just show you a little bit of that. Let me just jump to the methodology first to explain what it is. Sorry. Let me just show what the methodology is, and then I'll tell you a little bit about the data. Okay, so this is our procedure. This is how we started. Then I'm going to explain what we did. We had to trick this a little bit. I requested all the raw data. So I requested the interview data. So they said, I need you to give me every question that every firm answered on every survey that you send it. They couldn't give me that. Actually, it's not even clear that they have the data saved. They gave me a different data set, which was, a number that they have already assigned for something. So labor treatment. So how happy are the workers in my company? They assign a number to that. So they didn't give me the 5 questions that they use as input. Most of them didn't even find them. So I am really wondering if they were saved ever, okay? They gave me the rawest data that they could give me at that time. Now, it is conceivable that they were lying to me. I understand that. But I think that all of them were trying to do the same thing. And in some of them, we have more raw data than others. But anyway, but the idea is we got the closest one. So my intention was that, imagine that I have attributes. These are things that matter from the ethical point of view, which is a little bit of what I described. So one is treatment of consumers have many attributes, because I can produce something that is harmful to the consumer. That would be cigarettes. But I could also do something bad to the consumers because I do bad advertisement or false advertisement, okay? Or, Nestlé, for example, is famous for that they were telling the mothers in Africa that it was better to give the kids milk in powder than their breast milk, okay? Things like that, will give you very negative points. So, but it's not that the product is harmful, it's the marketing that is harmful, okay? So when you think about every one of these attributes, there are many, many categories. So water is how much water I use. Also, do I have a management of water emergencies, etc. So there, the environment, you will have like 25 of them. So plastic, do I throw plastic? Do I recycle the plastic? Do I verify that the plastic was recycled? Do I have pollution of CO2 emissions? Do I do something? Do I have management, etc.? So you can imagine there are many, many of these attributes. So what we wanted to do was to get the attributes from all the firms. This is what the intention was. I want to firm, I'm gonna talk about A2, okay? Can everybody see A2? Okay, so in A2, let's assume that A2 is how happy my workers are, okay? Now I cannot measure happiness, that doesn't exist, okay? So what we do is that one rating agency takes a proxy and they decide, I'm going to measure turnover. In fact, let me be more specific, because this is more specific. This is how women are happy in my company, okay? Women happiness of my workers. So one is I can measure turnover. So how much they quit and they are unhappy, so they leave. Or I can measure how many of them go to a court and file a complaint of sexual harassment. Now they are related, but they are not the same. And one of the things that happen is that these rating agencies, they choose how to measure the attributes. They tell you, this is what I'm planning to measure. By the way, we interview all of them. We interview the analysts. This was more than 3 years. We had to interview every analyst collecting the data. And the first question was, what is your intention? What is the intention of what you want to collect? Then what indicator do you get? Okay, because there's a difference between the two. And again, people have not realized those differences. So they tell you, well, my intention was to measure, the happiness of women in my workplace. I measure sexual harassment or labor court complaints. And there are many complaints of this, because you can have sexual harassment, but you can also have like a pregnancy, that you fire a woman when they're pregnant. That's illegal, I think, in every country, okay? So that they file a complaint on that one, and so on. So there are many different ways, there are many different reasons why a woman could go to a court and a labor court to file a complaint against the company, or they can quit, Okay, I mean, you assume conceivably both will be correlated, and indeed they are correlated, but they are not the same. So because they're not the same, we call this measurement disagreement. They are trying to capture the same intention, but they are not exactly the same. And the second thing that is very interesting is there were many, many attributes that were collected by one rating agency, but not the other. So there's no chance the ratings will ever be the same if you are collecting different data sets. By the way, these are completely different, like child labor and electromagnetic field have nothing to do one with the other. So that we call a scope discrepancy. It means that their indexes will not have a chance to be the same, and then they put them together in one single number at the end, and clearly there can be weight differences. That's the easiest one to understand. Okay, so our idea was we're going to match raw data at the attribute level. You see, so I know what the measurement error will be, then what are the scope errors, and then what is the weight errors. And what we want to know is the decomposition of that. Now, this was impossible because first, we didn't get exactly the super raw data. And second is because, we couldn't match the intentions. So it was impossible. So what we did was to create something in between. We created a set of very narrowly defined categories. I'm going to show you some of them. We have 64. It's too many to be able to show in the slides. But what we did was we have the attributes we know that we would like to measure. We have the indicators that we know we are measuring. And then we put them in categories that are relatively narrow, but not as narrow as the raw data, okay? But the categories, that taxonomy, the mapping from the indicator to that one was done is when we needed the interviews. And again, we use judgment in the creation of that taxonomy. So one of the advantages of the paper is that the taxonomy, we produce a taxonomy. One of the disadvantages is that it has a lot of criteria.
Roberto, sorry, may I interrupt? I have two questions. So yeah. Question number one, when you were talking about the first discrepancy, is it the same problem like with any proxy? For example, you're saying that they have an attribute, right? But then they measure it in a different way. So think of uncertainty, right? And there are tons of proxy for uncertainty. And so like one paper is taking one proxy, another is another. So does it have the same flavor basically?
Absolutely the same flavor.
Okay, and then the second question, do I understand correctly that basically what you're doing, you're taking this originally 10 companies, right? 10 different ratings, and then like when you move, you have the attributes, but as you mentioned before, you have two types of discrepancies, right? The first one, when you have an attribute and then you had like two different way of measuring, and then when you have like completely different attributes, unrelated. Yeah. So what you're doing, you're aggregating them.
The composition, right? Yes, absolutely.
So in the end, you will provide your own rating. Okay, but now the question. So your rating will be based on these 10, top 10. But you mentioned that you have 250.
Yeah, that's
so,
a
yes.
question, Marina. So no.
Sorry, comment on that.
I am on destructive mode. Okay, so I'm like, you remember Terminator? Okay, I am like Arnold Schwarzenegger now. Okay, so I'm just destroying this. I am not building anything. So I just tell them how bad is what they do. And so surprisingly, they still talk to me. I mean, I requested all the data this year, all the way to 2019, and everyone is giving me the data. So I think they're afraid of me. I did something to MSCI that I think was so embarrassing that I think that now they're really afraid of me. Okay, so that's so you're right. This discrepancy happens all the time in economics. For example, unemployment is a noisy measure. Now the difference is that we understand so much about unemployment, okay, and labor markets, and we produce 10 different signals of unemployment that a macroeconomist that understands labor markets correctly can form an opinion using all the 10 indicators and gets an assessment about what happens in the labor market. So one of the advantages of, for example, risk and unemployment, for example, is that we understand them so well that even though there are discrepancies on the measurements, we know to understand what these indicators are meant to reflect, you see? So that's one part that is different. If I ask you about child labor, how many of you actually know anything about child labor here? So very likely, not a lot, okay? Oh, but by the way, what Medina did is correct. If you want to ask a question, just interrupt me. I'm from Latin America. I am genetically designed to be interrupted, okay? So just go ahead, okay? Just ask me a question. But so the point is, the issue is that the discrepancies here are bigger and are different and are difficult to reconcile because we do not understand enough about the phenomena. So when we see a difference, we say like, why is this different? So for example, I mean, I have millions of examples, but just give me just one example. So Citibank, imagine that Citibank is treating badly their women, okay? Then Citibank US, what is going to happen is that the women will quit. Because in the US, when a woman goes to a labor court, it's a major stigma. And therefore it affects their life employment status. In France, they will actually stay in the job and file a complaint to a labor court. So same firm, same mistreatment will be measured very differently. So how do you measure? How can you construct an index with these two? When the culture of the place will determine a lot how the behavior will be reflected, you see? So this is one that, you know, I have spent a long time trying to understand discrimination. So, you know, I have taken 3 years of courses of psychology and social psychology, okay? So I have actually spent a long time trying to understand this. So now I can actually give you that example and then make some sense of what happens. But truly in practice, it's very complicated, some of these issues. So the discrepancies are harder to reconcile, and therefore that's what makes it different. Furthermore, there's not even an intent to reconcile, and the rating agencies very rarely even share the raw data with the clients. So for most people, they only get the R at the end. That's more or less what you get. If you go to Morningstar, you will only get R. Morningstar is one of the best rating agencies right now. They bought the best rating agency, in my view. Okay, so we had to create those categories to be able to compare. Is that clear? So it is imperfect because then there's an error that we will introduce on the taxonomy. So we will assume that things are the same when truly they might not be the same. So we are exacerbating the measurement error, okay? This exacerbates the measurement error because we're assigning to things to be the same when they might not necessarily be the same, okay? But again, after 3 years, we had to do that. And the two rating agencies that gave us data, we could not do the interviews yet, so we have not been able to do the taxonomy. So that's why they're not in the data. Okay, let me just show you a little bit. The rating agency, Sustainalytics is the one that was referring, that is one of the best. What I did with MSCI is that MSCI didn't want to give me the data. So I wrote the paper with the others, okay? And then I asked MSCI, I sent the paper to MSCI and I said, you know, MSCI is about 85% market share. They have a lot to lose by giving me the data. So I told MSCI, well, you know, here's the paper. We would love to include you in the research. He said, I will not look like a credible researcher if I don't request your data. And I said, in fact, if I need to pay for the data, I am willing to pay for the data. Just let me know how much you want for the data. And then they said, sent me an email, said, we will not give you our data, even if you pay. So I said, okay, thank you so much. So I wrote the paper, and in the first footnote, I put a copy of the email by saying, I requested the data from MSCI, and this is the answer that I got from MSCI. This is my email. This is their answer. And I said, you know, I prefer to look like a jerk than to look like an incompetent researcher. And I went to gave a presentation, and I put the disclaimer very big on the second slide. The next day, we got the data from MSCI. Okay, so this paper has been downloaded 14,000 times. So they actually gave us the data very fast. So it was very beautiful. So I think that now they're really scared about my reaction when they don't give me data. So that's good. It's good that they're afraid. Anyway, so let me just tell you discrepancy first. This is my preferred graph. I'm going to actually show you. You can go to the data. One way to understand the discrepancy is that we got the exact same firms for all the 5 ratings. I'm going to show you 5 ratings here. The exact same firms, exact same year for all 5 raters. So the sample is a little bit less than 900. Okay, so that's all the firms, all the universe. It's perfectly balanced panel. And I asked the question, I want to know who are in the top 160. Okay, this is not a small number. I'm asking who is in the top 160, and these are the only firms that are on the top 160. Very few of them. Now, what is very interesting about the data when you look at that, these are rankings. So I prefer rankings, which is the graph I'm going to show you, is really don't care about what the number is. So if I have 2 firms, one is ranked 1 and the other one is ranked 50, I will like that the other rater has roughly the same order. Is that okay? It's like the rank correlation. When you actually look at the rankings, the positions in the ranking, this is how the data looks. Let me just do a zoom here. Can everybody see a little bit of the zoom? So there are firms that all the rating agencies rank Peugeot very high, or Bayer, they rank them very high. Is that clear? Or Hewlett-Packard, they are ranked relatively high. The area that I'm showing you here is probably top 20%, top 15%. So there are many firms that there's agreement. And why I'm showing you this, these guys are very low rated. The blue is a rating agency that only gives letters like AAA, BBB. So there's not that many. I mean, you know, it's more sparse than the number of quintals that we have. Okay, so but I just want to explain why the blue looks like a straight line. Okay, so in general, what happens in the bottom is that you have many firms like Expedia, a lot of Japanese firms, because the data was from 2014. Again, it took 3 years to do the taxonomy, so it took us a long time. So the data is relatively old. And in 2014, what happened is that many firms in Japan did not answer the survey because of the tsunami of 2012. So in 2012, they did not answer the survey. In 2013, so by 2014, they got a very bad rating. Okay, so, but this data, you can see the tremendous accuracy. You see how tight the band is, no? The correlation of the ratings here is about 91%, 92%, which is the exact same correlation that you will get from credit rating agencies when they are rating individuals. Okay, so this is how the rest of the data looks. So this is my confetti paper. Okay, this is my confetti graph. You have many firms that are on the bottom 5% for one rating agency and the top 20 for the other. This is beautiful. By the way, they are organized, they are sorted by the median. That's why this looks like there's a line in the middle, is we took the median measure and organized it along that line to have some, you know, some guiding. But this is how the data looks. So in other words, if you want to invest in Hitachi, you use this rating agency. But if you don't want to invest in Hitachi, you use this rating. Like it doesn't matter. You get, depending on who you want to invest, you just use a different data set. And by the way, this is happening in the data. Go to the paper and you will see the names. They are all over the place. Okay. Oops, sorry, I made too much of a zoom. So let me explain a little bit about the categories. This is an example of the category. We had to ask permission. We have severe NDAs. We cannot reveal the names of the variables, but they allow me to do this for water. So, for example, asset 4 was Thomson Reuters. Okay, so in asset 4, there are 3 measures of water, and we know they're water. Okay, so therefore we assign them to water, the category water usage. So, by the way, one is water use, water recycling, and stuff like that. Then KLD is a very famous data where a lot of the research has been done. It's a public data source. It belongs to MSCI, and they have this measurement, which is one is water stress and the other one is water management. I always wonder what water stress means. I have no idea. So what? Stress on what? On the supply of the water? On the, I mean, like, I'm stressed because I have no water? I mean, like, I have no idea. Or is it dependency? Maybe water stress means that I depend a lot on water for my production. So if in the absence, I will have a lot of stress. Water management, I think it makes sense that you have procedures about waters. The water operations. You see how hard it is? By the way, the only ones that are common are KLD and MSCI. The MSCI data is water stress management, and the KLD is water management, water stress. So you know that these two groups are probably close to each other. Now I have to say something very important. MSCI owns KLD. So this might be even the same data. So the reason why they have the same name is it's the same company. So, by the way, the analysts of KLD do not exist anymore. So we could not ask them about what the intentions were. Is that okay? We have to base our decisions on the documentation. But I would say that 90% of the finance papers have used KLD. So that's why it was very important for us to include this data source. Robeco-san was the most prestigious data, but it was not public at the time when we got the data. This was used, today is public. I think it's a Standard & Poor's is the one that owns this. There has been a massive consolidation, and Sustainalytics is to me is the best. So it's kind of hard to do the mapping at the individual level. So we have to choose this category of water. Then another one would be CO2 and so on. So let me see if I have here. Oh, here is some category example. Sorry. Here are the categories. These are the correlations at the category levels. I want to show you many negative numbers. This is how bad the measurement is. You see, Medina? Like I take health and let me take one that is like super depressing. Customer relationships. They are negatively correlated among almost all the rating agencies. How is that possible? Like, first, what on earth is customer relationships? But then how can you be so bad that they are negatively correlated? Another one, labor practices. I love that one. They're negatively correlated. This is even public information. How can this be negatively correlated? Things like, so the issue is, you can see the correlations are very, very small. The other one is responsible marketing. I mean, I think that this should be a relatively easy way to judge when marketing is responsible or not. Are you lying, yes or no? But anyway, those are negatively correlated. In fact, many are zeros. Oh, thank God for 168. That's Robeco-san and Sustainalytics. So very few are green. Now, some of them are very high. Some categories are measured by all, like for example, employment development. You can see that there's a correlation on all, health and safety, green products, labor practices. Some categories are for all the rating agencies, but you can see how many whites are here. These means that many of them are not measured. That's the scope. So this just gives you an idea. These are not all the categories. I couldn't fit it in the slide, but if you go to the paper, you will see all 64. Okay, so there are many. So for example, child labor is something that is only measured by 2 rating agencies that are KLD and Asset4. Only 2 measure child labor. It's like, wow, that's a kind of an important issue about ethical behavior. How can we not be even measuring that? So anyway, so just wanted to show you more or less how they look like, okay? Now, what we do is we reverse engineer every one of them. Let me just put this a little. The slides are very packed. I will send the slides to Anna, and I will send the paper to Anna. Is that okay? So Anna will be the source of all the information. So I have to do the Zoom because, and by the way, you can see the little dots there. I try to reduce this, and still is just tiny letters. But I just want to show you a little bit of what we did. So we take the data, we put in the categories, but now we have new categories are not the true raw data from the rating agencies. So we needed to create a new set of weights to explain the final rating. So we needed to reverse engineer this. We applied something like 6 different methodologies from neural networks and random forest to OLS regressions. This is the one that works the best, which is OLS with a sign restriction. Every category, every raw data that they gave us implied that bigger numbers were better. So if you have a larger number, means that you are better on that particular category. So animal welfare, the higher number means that you are caring more about animal welfare than a lower number. So the raw data that we got from them already has been processed. So higher means better. And the rating higher means better. So what we did was to just run a simple OLS regression between the now, but remember, it's the taxonomy. It's not the raw data. It's the raw data. We put them into categories. Within each categories, we computed an average of the indicators that belong to that category. And now we have a new raw data, and we are going to construct a rating at the end. To do that, we just run a regression, an OLS regression, where we force the coefficients to be greater or equal than 0. So the ones that get zeros actually have tiny weights in general. The ones that are the little dash is that the data does not exist for that attribute or that category for that Robeco set. In fact, let me talk. These are our categories. So you see, board composition, board diversity. Robeco-san doesn't collect board diversity. Okay, so therefore that's why it has the dash. But asset 4 collects it, but in the case of asset 4, they put a weight that is either captured by other variables here, okay, in the regression, but the regression assigned as 0. By the way, we did this with Lasso and we got very similar results as well. Okay, so we did this 6 different ways, 8 different ways. It just, we get very accurate estimations. You see the R-squares are between 90. So this is about reverse engineering. So we want to get relatively accurate estimations. Here it is. Here are the summaries. Okay, this is more or less the accuracy that we get from using different methods and then using a different categorization. We did 2 taxonomies. One is the one that I just showed you, and the one is the Sustainable Standard Boards. Okay, the SASB. Okay, so then we do a decomposition. It's very easy. For every, I take any firm between 2 rating agencies, I want to know how much is the measurement. So this has to be the common categories. I look at the differences on the numbers on the categories. Then the weights are very simple. I have the common categories. I look at the different, weights that they assign from the previous regression. The W star is a common weight for all of them. And the scope, well, I mean, the scope are the indicators times the coefficient that I have that the other rating agent doesn't have. This is a super simple decomposition. I mean, by the way, this is by construction has to be true. So we call the first component measurement. So we said, well, we have a common weight. We only look at common categories, differences in measures, okay? And that we call that way a measurement. We call the scope the contribution on the final rating that comes only from the categories that are excluded, okay? So this, remember, this is kind of the fitted value, okay? This will be the fitted value from the categories that are in rating A that are not in rating B. So it's the numbers times the coefficients. So that will give me the contribution of the scope. So this will be the error made by the scope. And this guy here is the difference, and we call that weight. Is that okay? And again, this is the actual rating. Now, we are doing this on the fitted value, so we know that this the composition will be true. At the end of the day, there are additional errors that come from the fact that the fit is not perfect. Okay, so we then compute the decomposition on all the pairs about how much is a scope, how much is measurement, how much is weight, and how much is the fitted value. Okay, so the fitted value, this is the differences, the average differences, the absolute differences that exist on the fitted value. This is on the true. You see the fitted value on KLD only drops about 4%, okay? There are some that are a little bit bigger. This one, it will be 9. But in general, the true difference is using the rating from them. The fitted is the differences between the rating that we constructed. So I mean, the accuracy is big enough that the difference on the absolute deviations are relatively small. And again, everything has been normalized, so has mean 0, variance 1, and that for the ratings. So this is, you can think about this as 4% is 4% of the standard deviation. Okay, good. Let me just show you one really cool thing. We're constructing this app is how can you move from one rating to the other. So for example, this is one company, it's a gold company, okay? And what we do is we said, well, what is the rating from asset 4? So that company has a rating of 0.5. That's 0.5 standard deviations above the mean of the whole sample of asset 4. And that same company for KLD has a -1. It's bigger than -1, but for the sake, let's just say -1. So you see, these are very different ratings because one is putting that on the -1 standard deviations on the distribution, the other one is putting on the 0.5, okay? So that will be kind of a top 20 and bottom 40, okay? So what we start doing with this app is we're trying to see only 4. Can you find 4 that move you from one place to the other? Is that clear? So we have the residual, which is the error that we made in the estimation. So in other words, when we did the fitted value for Barrick for asset 4, we did not get 0.5. We got a little bit bigger than 0.5 was this number. That difference is the residual. And then we start adding scope, measurement, and weights. We get the residual of the other, and then we get to the other rating. So we are producing this in which is like a lasso approach. We said, well, I know that we have 64 possible categories and 64 possible weights, so there's a lot of things that can be changing. By the way, about 90% of the difference is explained by a very small subset of things that are happening. So the way we're doing this is let's pick 4 on scope, 4 on measurement, and 4 on weight. This is simpler. The way I want to do it is to pick 12 of any. Is that okay? I said, like, just give me 12. By the way, 12 is kind of the 10% of the possible things that can be changing. So I said, well, 10%, I can find 10% factors that explain the rating, the discrepancy between one rating and the other. Now, this is a mining company. So you see, there's a big discrepancy on biodiversity. I think that that's bad. I mean, this is something that should be improved, you see? So community and society, that's the impact that the mining company has on communities. Another one that is related to that is indigenous rights, which is similar to community. We separate them just to give you an idea. So my point is, the reasons of the discrepancy are kind of important. If this were, I don't know, electromagnetic field pollution, you say, well, who cares about that crap? Is that clear? You see my point? So we're in our decomposition, by the way, this is not on the paper, this is kind of what we're trying to solve now, is that we want to understand from all the disaster that you observe, how can you make sense? And by the way, if the discrepancies are meaningful or not. For example, things like taxes, I might not care too much about taxes. In fact, if they pay or not, I'm fine. The board composition, I care because, I have, daughters and sons, so, I kind of care. But to be honest, maybe you don't care. So this social discrepancy, you don't care. You want to pick one of the two. The idea of constructing this is to try to provide a roadmap, which is what Medina wanted, to provide a roadmap of how can we construct something that is meaningful? How can we construct something that we can use in practice to make decisions? Should I invest in Barrick, yes or no? See, if I take asset 4, the answer is yes. If I take KLD, the answer is no. We like to know what makes me switch that decision. And switching from asset 4 to KLD, I'm switching on things that truly are very important for mining, like indigenous rights, business ethics, community and society, biodiversity, toxic spills. Give me a break. Okay, this sounds like core activities in mining, and we disagree on those, then we have a problem, you see? So this is one where the differences, I think, are going to be very difficult to reconcile. And again, the weight differences, my reaction is, well, conditional on the investors, there should be no weight differences because I know what matters to me. So conditional to me, I want 20% on this and 10% on the other, you see? So if the rating agencies share, this part here is the one that I'm advocating now for the European Commission. If we share the raw data, then all the weight differences will disappear. And all the scope differences will disappear. All the green and all the purple needs to disappear, because conditional on the investor, if I care about child labor, then you need to put something on child labor.
Roberto, I have a question.
Yes.
I'm very sorry again to interrupt.
Yeah. Go
But thinking about weight, you are saying that we should not have disagreement on weight, but on the other hand, you were bringing like an example when you have, if I remember correctly, the Citibank, right? But in 2 different countries. We can think of other example when you have like different cultures and because of, or different preferences. Yeah. And because of that, can't we have like different, for example, in some countries, in more developed countries, people care more about the environmental issues. In some other, they think about that
growth,
less amount of time. Yeah. So can they explain? Can these features explain the difference in weighting then?
So yes. This is because Medina, they are trying to. So very good question. So and thanks for interrupting. I mean, please interrupt me all that you want. Are you kidding me? So the way I think about this is they are trying to construct indexes that appeal to a very broad set of investors. And I think that that's the wrong approach. They should ask you, so Medina, all the $1 million that you have in your checking accounts, is that okay? So all the money that you have, clearly, because if you have all those books, then you probably have spent a lot of money, okay? So you have all this infinite amount of money in your checking and your savings account, and you would like to deploy that reflecting your values. So to you, there's no definition of discrepancy. See, so for you, you said, well, there might be measurement discrepancy. That's correct. So I don't know how to measure labor treatment in France and the US. That's measurement. That's the blue line. That's a hard one to solve. By the way, give me some time and I will give some ideas about how to solve it. But in the process, I'm trying to work on the blue line. But forget about the blue line for a second. If you said, well, I care about the environment and I don't care about communities. I don't care about biodiversity. So imagine, I know that makes you sound like a bad person, but you say, well, to me, environment is way more important, CO2, than biodiversity. I want to have everything that measures according to CO2. So you know what? Sustainalytics should build an index for you, Medina. They take the raw data, they have their categories, you tell them what matters to you, and I build an index for you. I give you your ranking, and then with that ranking, you decide which firms you want to invest and which ones you don't. So it will be consistent to your preferences. Now, when Ruben comes, he says, no, I only care about biodiversity. Or let's say that Ruben is more balanced. So he wants biodiversity and CO2. So he wants 50-50. So then Sustainalytics produces an index for Ruben. And then Anna comes and said, oh, that's you have no idea. How can you not include child labor, you bastard? Then Anna has one third. No, not fact, actually. Anna have 40 child labor and then 30 and 30. So see, my point is that conditional on the individual investor, weight differences should not exist. I mean, this purple or pink, I don't know what color is coming on your side, but anyway, these last four, that's a no-no, should not exist. And the same with the scope. In the scope, if something matters to me, you better put a number and a weight for me. So you see, the green and the purple, I think we can solve. And by the way, that's what I'm trying to advocate the regulators to do in the European Commission. And that reduces the discrepancy that I just showed you by about 47%. So 50%, half of the confetti disaster can be resolved by solving these differences on a scope and weight.
I have to say that we're running a bit out of time, and I know that you have another meeting back to back. So I'm afraid that you may start getting late to your next meeting. So let's.
No, I don't. I have my watch. It has not vibrated yet. That's no. So, by the way, that's more or less what I wanted to show you. So the paper is that decomposition, and the next one is for example, the next paper we're doing is estimating what the returns should be. So if you wanted to use this data to estimate like a Fama-French regression, how do you estimate that correctly when you take into account that the rating that you are putting on the right-hand side is incorrectly measured? So that's kind of the next paper. So it sounds that's way more financy. So the next time Anna invites me, and at that time I will be in Moscow, I can present.
Well, let me invite you on behalf of everybody to Moscow. Hopefully we can welcome you here. And thank you very much for giving this nice talk. And we'll be very happy to see you here really in Moscow. So hopefully sometimes it will happen.
Perfect.
Thank you very much.
No, thank you for your time, and good luck, and thank you for everyone that met before. I actually had a very good time. So I hope that we can repeat this, but in person. There's no substitute to human contact. Okay, that's a fear of life now. Good. Thank you.
Okay.
Thank you.
Thank you.
Thank you. Bye-bye.
I'll send the
Thanks
paper.
a lot.
I can send the paper. I'll send the slides. Okay.
Yes, we'll put it on the website at the New Economic School.
Bye-bye. Thank you.
Thank you. Bye-bye.